In this video, I'm going to go over how to use trig functions to find a missing angle inside of a right triangle. And so we're going to be using sine, cosine, and tangent, and the acronym most often used to remember the ratio of the sides is SOHCAHTOA. So we have sine, which is opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse, and we have tangent, which is opposite over adjacent. And so we're actually going to end up using the inverse of these functions to find a missing angle. When we found missing sides, we just used them directly. So here we go. First thing first is always to figure out what your sides are labeled based off your angle. So my angle is X, angle P is what we're looking for. Across from the angle is called the opposite side. Next to the angle is called adjacent. And we know across from 90 is your hypotenuse, but we don't need the hypotenuse in this situation. All right, so because I have opposite and adjacent labeled, that means I'm going to be using tangent. So the tangent of angle X is equal to opposite 41 over adjacent, which is 100. Now we need to get the angle out of tangent, essentially. And without going like too far in depth here, opposite operation of tangent is inverse tangent. And so if I take the inverse tangent of the left side and the inverse tangent of the right side, I'm left with just X equals the inverse tangent of 41 over 100. So some people go straight, when they know they're looking for an angle, they go straight to this step to say, oh, okay, I know I'm using inverse trig functions because I'm missing an angle. And then I'm going to type this into the calculator. If you're using Desmos, you need to make sure that your wrench tool is in degrees. And then to find the inverse tangent, you just click on the functions button and there's inverse tangent and bad memory, what were the sides? 41 over 100. And that gives me 22.3 if I'm rounding to the nearest tenth. So I have 22.3 degrees. All right, another example. We have X here. I'm gonna label my sides. I have across from 90, that's called the hypotenuse. I have next to the angle that's called adjacent. So since I'm dealing with adjacent and hypotenuse this time, that is the cosine function. So I have the cosine of angle X is equal to the adjacent over the hypotenuse. And then I'm going to take the inverse cosine of both sides, and that will leave me with X. And so I'm going to do inverse cosine 12 over 20. You don't have to write it out as an extra step like I did in the first example. I can just go ahead and type it in. And I have 53.1. And it's in degrees. All right, the last example here, I've got angle X. Across from this angle is called the opposite. Across from 90 is called the hypotenuse. And so I would have the sine of angle X is equal to the opposite over the hypotenuse. And then I'm going to get X by itself by taking the inverse sine of both sides, and X is equal to inverse sine of 16 over 20. And I have 53.1. Again. So what this would mean, guys, is that this side would be 12. Because when we did the cosine of the angle, which was the adjacent over the hypotenuse, we got 53.1. And the other side was 20, so that would mean that that one would have to be 12. And you could even check it using Pythagorean theorem, like doing 16 squared plus 12 squared. That wasn't part of the problem. I just wanted to point it out that you can do that. Also, if you need the next angle in a right triangle, you wouldn't use trig again. Instead, you would just do 180 minus 90 minus 53.1, and that would have given you angle T if you needed all the angles. So that is inverse trig and how to use it to find a missing angle in a right triangle.